Alright, next set of directions are asking us to choose the ordered pair, which is a solution of the inequality. There may be more than one answer. So what we're going to have to do is we're going to have to take each ordered pair, okay, and we know an ordered pair represents an x value and a y value. So in that first ordered pair, your x value is a -1 and your y value is a +1, and we're going to plug that into our inequality. So our inequality says that 2 times our x value, which is -1, minus 4 times our y value, which is +1, has to be less than 6. Okay, the right-hand side is worked out, but the left-hand side is not. So we're going to simplify the left-hand side by using our order of operations. So we check to see if there's anything to do inside our parentheses, and there's not. And then we see if there are any exponents, and there are no exponents. And then the next thing we're supposed to do is multiply and divide from left to right. So I don't have any division, but I do have some multiplication. So 2 times -1 is -2. You can do a couple different things here. You can bring down the subtraction sign, okay, and then just do 4 times 1. Or you can consider the 4 to be a negative number. I kind of prefer that second way, or second method. The 4 is technically negative because it's being subtracted. So you have a -4 times a +1. That means I have a -4. And then we're checking to see if this is less than 6. Still simplifying the left-hand side. -2 minus 4. Those numbers are both negative, so you'll add those numbers up and keep the sign. So you'll get -6 is less than +6. And you're going to ask yourself whether this is true or not. If it's true, then the ordered pair -1, 1 is a solution. If it's not true, then the ordered pair is not a solution. So you ask yourself, is -6 less than +6? The answer is yes, that's true. So if that's a true statement, then that means -1, +1 is a solution. Now the directions say there could be more than one answer. So we have to keep checking all of the answers. So in the second ordered pair, x is +2, y is -2. So I'm going to kind of go a little bit quicker through these because I've showed you how to plug in 1. So the second ordered pair would look like this. 2 times 2, since x is 2, minus 4 times y. Y is -2. We're going to do our order of operations. There's nothing to do in parentheses, no exponents. Then I'm going to multiply from left to right, so I have some multiplication problems here. 2 times 2 is 4. The -4 times a -2 is a +8. 4 plus 8 is 12. And then you're going to ask yourself, is 12 less than 6, true or false? 12 is not less than 6, so that's a false statement. If that's a false statement, that means 2 -2 is not a solution. And then you're going to do the same exact thing with all of your ordered pairs that you may be given in a problem. And so the last two, I'm not going to do the work for those, but the work would just be just the same, and they come out not to be ordered pairs. So only a solution, so only -1, +1 is a solution. In number 27, they're asking us to graph the linear inequality. We have not done any linear inequality, so if you're wondering, I've never seen a problem like that before, you're right. We did not have any in our worksheets. When you're graphing a linear inequality, it's very similar to graphing a line. If you'll notice, this inequality is already solved for y, so it's in y equals mx plus b form. So we know that our slope is the coefficient of the x. So our slope is -4. And we know that our line is going to cross the y-axis at +1. +1 would be our y-intercept. Slope is rise over run. So if you're ever given a slope that is a whole number, like -4, you can always put it over 1. So you have rise and run. So I know that this line is not going to rise from left to right, it is going to fall. So when I graph my line, I always start with my y-intercept. It's a +1, so you'll go up 1 on the y-axis. My slope is -4 over 1. So when instead of rising, since the 4 is negative, I'm actually going to fall down 4 units. So from the y-intercept, I'm going to go down 4, and then I'm going to go to the right 1. If I go down 4 and to the right 1, that's going to make sure that my line is falling instead of rising. That's what a negative slope means. It means your line's actually falling from left to right instead of rising. Then I'm going to go down 4 units again from that point and to the right 1. Again, you only really have to have 2 points to graph your line, but it's nice to have more than 2 points sometimes. Later on, you may be trying to, in other math classes, trying to get 2 lines to intersect. Sometimes you have to create more points to get your lines to actually cross. And so using that slope to generate multiple points would always be a good thing. Now, this is not an equation. It's an inequality. So let's talk about this. We have an inequality. It is less than. Anytime you have a less than, you're going to shade below your line. Anytime it is a less than, you're going to shade below the line. Anytime you have a greater than sign, you're going to shade above the line. So since we have a less than, we're going to shade below the line. We're going to shade all the points below the line. We're also going to have to make a decision of whether our line is solid or whether it is dashed. So we look at the inequality sign again and we see if there's an equal to there. Nope, it's just y is less than. It's not y is less than or equal to. So if there's not an equal to, then that means that my line is not solid. It is dashed. If it did have an equal to, then the line would be solid. So because there is not an equal to, your line is a dashed line. If there would have been an equal to, then it would have been a solid line. And again, less than, you shade below. Greater than, you shade above. Next set of directions say evaluate. That's just for number 28, and we know anything raised to the 0 power is 1. If you're not sure about this, you could put it in your calculator. You could do parentheses, -10, close parentheses, hit your power key, put in 0, and it should give you 1. In number 29, we are asked to simplify and write the answers with only positive exponents. So first thing that I notice is I have a coefficient of -5. It is not an exponent or a power. It is a coefficient, so I actually have to raise -5 to the 5th power. So that's -5 times -5 times -5 times -5 times -5. 5 times. That gives me -3,125. And then I have a rule that says anytime I have a power or an exponent, those are the same terms, raised to another power, I'm going to multiply. So 4 is raised to the power of 5, so 4 times 5 is 20. The power on the y is an understood 1, and again, anytime I have a power to a power, I'm going to multiply. 1 times 5 is 5. So that would be my answer. On number 30, we're actually multiplying two variables together that have like bases. So we have an exponent rule that says when we multiply two variables that have like bases, we add their exponents. So 1 plus 4 would be 5. So my answer would be x to the 5th. Same thing in 31, we're multiplying all these x's together. So we're going to add their exponents. 6 plus 7 is 13. 13 plus 4 is 17. At number 32, we're dividing. In the top, we have -16. We'll do our coefficients first. -16 divided by a +8 is a -2 in the top. When we're dividing like bases, when we're dividing our x's, we do that by subtracting the exponents. We always move the smaller exponent wherever the larger one is to subtract, and that's where we leave our answer. So we're going to move the 2 up. Since 2 is smaller than 9, we're going to do 9 minus 2. And that's going to give us 7. And since we moved up, x to the 7th would be in the numerator. Then we're going to divide our y's. Y to the 12th divided by y to the 9th. 9 is smaller than 12. So the 9 moves up to the larger exponent. We subtract 12 minus 9. And that gives me y to the 3rd. So I technically have a 1 in the denominator, but we won't write that 1. Okay. That's an understood one. You can write it if you want to, but you don't usually see it there. And then that would be my answer, -2, x to the 7th, y to the 3rd. In number 33, I have a fraction inside parentheses raised to a 3rd power. So I'm going to start with my coefficient of 5. 5 is not a power. It's not an exponent. It's a coefficient. So 5 to the 3rd power is 5 times 5 times 5, which is 125. Then I'm going to use my power to my power rule. 4 raised to the 3rd power, you multiply 4 times 3 and you would get 12. On the bottom, I'm going to use my power to my power rule. And b to the 5th raised to the 3rd power, 5 times 3 would give me 15. Number 34, 4 is a coefficient. 4 to the 3rd power is 4 times 4 times 4, which is 64. X to the 4th raised to the 3rd power, power to a power, multiply gives me 12. Multiply 2 times 3, power to a power gives me 6. On the bottom, z to the 4th raised to the 3rd power, again I have a power to a power, so I'll multiply 4 times 3 and I get 12. Perform the indicated operations. In number 35, the indicated operation is a subtraction problem. So they're asking me to subtract these two trinomials. So you can drop the parentheses and bring down the 3 terms in the first parentheses. But since the second parentheses is being subtracted, you have to distribute a -1 times everything in the second parentheses. We always do that when we're subtracting, because subtracting is the same as multiplying by -1. It means we've got to change all the signs. So I get a -4x to the 4th. A -1 times a +6x to the 5th is a -6x to the 5th. And a -1 times a -10 is a +10. Now we just have a bunch of pluses and minuses. That just means we're combining like terms. So start with your highest exponent, x to the 5th. Look for any other terms that have x to the 5th. I have another term here, -6x to the 5th. I'm going to combine those together by doing 9 minus 6. So we're going to get 3x to the 5th. When you're combining like terms, you do not change your exponent. You just combine the numbers out in front. Then let's see, our next term is an x to the 4th. It's going to combine with -4x to the 4th because those are like terms. And again, you only combine your coefficients. So 20 minus 4 is a +16. And we keep x to the 4th because we're adding and subtracting here. So we're really just combining like terms. And then we have the +5 and we have the +10. Those are like terms and they combine to be +15. So that gives me my answer. In number 36, the indicated operation is adding. When we're adding, we just bring down all the terms. None of our signs will change when we're adding. Our signs only change when we're subtracting, and we change the signs of the terms that are in the parentheses that we're subtracting. So we're not subtracting here, so we can just drop the parentheses, underline our like terms, 3x and 6x combine to be 9x, 4 and 2 combine to be 6. So we get 9x plus 6. Next set of directions are telling us to multiply. So remember, when you're multiplying like bases, you're going to add the exponents. So we're going to start with 6p. We're going to distribute 6p into the second parentheses. 6p times 36p squared is 216. P times p squared, add the exponents, p to the 3rd. 6p times +6p is a +36p squared. 6p times +1 is a +6p. Then we're going to distribute the -1. -1 times +36p squared is -36p squared. -1 times +6p is -6p. And -1 times +1 is a -1. I have no other p cubed terms, so I'll bring down my 216p cubed. I have a +36p squared and a -36p squared. Those are like terms. They're actually going to cancel each other out because one's positive 36, the other one's a negative 36. And then I have a positive 6p and a negative 6p. Those are like terms, but they're going to cancel each other out. And then I have that minus 1. So that's my answer. 38 is a binomial times a binomial, but we're going to work it exactly the same. We're going to start with the x, and we're going to distribute the x into the second parentheses. X times x is x squared. X times negative 4 is negative 4x. 4 times x. Positive 4 times positive x is a positive 4x, and positive 4 times negative 4 is negative 16. We have two like terms in the middle, but they are opposites, so they will cancel each other out. And your final answer is going to be x squared minus 16. W minus 9 squared. This is considered a binomial squared. Doesn't matter what level of math students I have. A lot of people miss 39. What I would like for you to do is to always write it down twice. This helps you not make a careless mistake. W minus 9 squared is actually W minus 9 times itself 2 times. So you actually have a binomial times a binomial, and they'll work it out. We will work it out just like number 38. So we're going to do W times W. That gives you W squared. W times negative 9 is negative 9W. We're going to distribute this negative 9. So negative 9 times positive W is another negative 9W. And negative 9 times negative 9 is positive 81. The two middle terms are your like terms. I don't have any more W squared, so I just bring down my W squared. A negative 9W and a negative 9W do not cancel because they are not opposites. So you combine negative 9 and negative 9, and that gives you negative 18W. And then you bring down the plus 81. And that is your answer. If you remember in class, I did show you a shortcut for this one. And that shortcut was square, double square. Most of you did not like this, and you said you would do it the long way. But some of you may remember it, and it will be helpful once you get to some harder math classes. When you square double square, you're going to take the first term, which is W, and you're going to square it. Then you're going to multiply the two terms together. W times negative 9 is a negative 9W, and you're going to double that. So it's like you have two of them. And when you have two negative 9Ws, that means you really have a negative 18W. And then you're going to square the negative 9. Negative 9 times negative 9 is positive 81. So this is just a little shortcut for squaring a binomial. You can do it the long way, you can do it the short way, whatever floats your boat, as long as you get the right answer. Number 40, evaluate the polynomial. Evaluate means work completely out until you get one answer. And so what they're telling us is they're telling us that x is equal to 5. And they're telling us y is equal to 2. So that's saying wherever you see an x, you're going to substitute in a 5. And wherever you see a y, you're going to substitute in a 2. So you're going to do, instead of doing x squared, you're going to do 5 squared plus 3 times y squared. So instead of a y, you're going to substitute in a 2. So it'll be 2 squared because it was y squared. And then you're going to have plus 2 times x, which is 5, times y, which is 2. So we're just substituting in 5 for x, y for 2, and then we're going to follow our order of operations. So remember, we'll do our parentheses first. We actually don't have anything to do inside of our parentheses because we just have one number there. And then we go to exponents. So I actually have two numbers raised to exponents. So I'm going to do 5 squared. That's 5 times 5, which is 25. Bring down my plus. Bring down my 3. 2 squared is 2 times 2, which is 4. And then I'm going to bring down the rest of my problem. So again, I'm following my order of operations. Please excuse. Nothing to do in parentheses. I did my exponents. Then I'm going to multiply and divide from left to right. So I do have some multiplication going on. I have 3 times 4, which is going to give me a 12. I have 2 times 5, which is 10, and 10 times 2, which is 20. And then I can bring down my 25 plus 12 plus 20. So I multiplied. I don't have any division. And then it says add and subtract from left to right. I have no subtraction, so I'm just going to read from left to right. 25 plus 12 is 37. And then I'll do 37 plus 20, which finally gives me the answer of 57. Again, evaluate means work out all the way out till you get one answer. Find the GCF. Find the GCF, greatest common factor. So when we're doing variables, we look at all the terms. If they all have an x, and they do, x, 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 we go with the x that has the smallest exponent. So that would be x cubed. And then we look at our y's. To find our GCF, we ask ourselves, do all the terms have y's? And they do. And we pick the y that has the smallest exponent. That's how we do GCF with our variables. So x cubed, y cubed would be our GCF. For numbers 42 through 47, the directions say factor completely. So let me remind you, they're not going to tell you which specific method that you're using, but when we're factoring, we have 4 different ways that we can factor. We can factor with GCF, and we always need to check the problem to see if there's a greatest common factor. We know how to factor difference of squares. That would be a binomial. We know how to factor trinomials, those that are easy and those that are hard. And we also know how to factor what we call grouping. And the clue that we're factoring by grouping is our problem either has a group in it to begin with, a common group in it, or it has 4 terms. So when we look at number 42 again, we always want to ask ourselves, is there a GCF? So between 5 and 25 there is a GCF. That would be 5. Between x squared and x to the understood 1 power, then our GCF is going to be that smaller power. It'll be x to the 1. So we're going to factor out our greatest common factor of 5x. So we say 5x times what is 5x squared, and that would give us an x. And then we say 5x times what is 25x, and that would be a positive 5. And again, we can double check just mentally by distributing the 5x back into the parentheses. 5x times x is 5x squared. 5x times positive 5 is positive 25x. Now this x plus 5, if it could factor again, you would have to factor it again, but it will not factor again. It is not the difference of 2 squares since it's a binomial, and that's the only thing that it could possibly be for me to factor again. So x plus 5 does not factor again. That means you're finished. 43 has 4 terms. Anytime you have 4 terms, that is a clue that you're factoring by grouping, and we usually group the first 2 terms together and the last 2 terms together. The first 2 terms have a greatest common factor of x squared. So I'm going to factor out an x squared. I'm going to say x squared times what is x cubed, and that would give me an x. Then I'm going to say x squared times what is positive 8x squared, and that's going to give me a positive 8. So my group that I just got from factoring out the GCF is x plus 8. So I'm going to cheat just a little bit, and I know my group over here also has to be exactly the same group. So it's going to be x plus 8. So then I ask myself, what can I multiply times x plus 8 that will give me 3x plus 24? And the answer to that question is positive 3. Double check by multiplying that positive 3 back into the parentheses of x plus 8, and sure enough you get 3x plus 24. Now my common group is formed. I can actually factor out the x plus 8, and when I factor out the x plus 8, I'm left with x squared plus 3. Neither one of those factors factor again, so this would be my answer. Again, they're asking me to factor completely. On number 45, I have a trinomial, and we know how to factor trinomials. This is a harder trinomial because of the 10 in front of the z squared. So I know I'm going to go ahead and do my parentheses. To get 10z squared, I have a couple choices. I could do 5z and 2z, or I could do 10z and z. So I always like to try the 2 factors that are closest together. So I'm going to start with 5z and 2z. Since the 9 is negative, that means I have to have two things that multiply together to be negative 9. And since 9 is negative, that means my signs have to be different. If I'm multiplying two numbers to get a negative 9, my signs have to be different. Now there's two different possibilities. We can do 1 and 9, or we can do 3 and 3. We can do 1 and 9 or 3 and 3. We'll try 1 and 9. So since this is a harder trinomial, you've got to check your outer terms. You've got to multiply your outer terms and you have to multiply your inner terms. And then you have to see if those two terms combine to be the positive 9z, and they don't. That's what stinks about the harder trinomials. So then the next thing that you would do is you would swap the 9 and the 1. You would multiply the outside terms and get negative 5z. You would multiply the inner terms and get positive 18z. And then you would check to see if negative 5z and positive 18z give you the positive 9, and they don't. So that stinks. So what that means is it's not 9 and 1 because you've tried them in both spots, and that means hopefully it is 3 and 3 if you haven't made any mistakes. So the outer terms multiply to be negative 15z, and the inner terms multiply to be 6z. And negative 15z and positive 6z combine to be a negative 9z. So we're really, really close. We just have to have a positive 9z. So if you combine your outer and your inner products and you get the opposite signs, that just means that you have to swap your plus and your minus and make it a minus and a plus. When you do that, the outer terms are going to multiply to be positive 15z, and the inner terms are going to multiply to be negative 6z, and 15z and negative 6z do combine now to be that positive 9z. So you have your two factors. Neither one of these factors factor again, so you're good to go. Sorry, just now saw 44. Let's go back up to 44. 44 is another trinomial. This one's going to be easy peasy since we've already factored a harder one. This one's easy because it's just an x squared, so I know my only choices here are x and x. 55 is negative. Anytime the last term is negative, that means the signs are different. If the last term were positive, that would mean the signs were the same. So since 55 is negative, my signs are different. And then this is one of those that you can say, what multiplies to be 55 that combines to be 6? And this time, since my signs are positive and negative, that means that we're really subtracting the 1 and the 55 to get the 6, or we're subtracting the 5 and 11. So it is going to be 5 and 11 that subtract to be 6. Now I have to decide which one's positive and which one's negative. Well, if I want my middle term to be positive 6, then I need my bigger number to be positive. So 11 is going to be positive and 5 is going to be negative. If you want to check here, you can. You don't necessarily have to, but just to show you, when we multiply the outer terms, we get a negative 5x. When we multiply the inner terms, we get a positive 11x. And negative 5 and positive 11x do give you the positive 6. So we have the correct factors here. So I just want to talk about what if the last term was positive. So just to kind of give you an example here, if you had something like x squared plus 5x plus 6, and we were factoring and the last term was positive. So again, if the last term is positive, that means your signs are the same, because same signs multiply to be a positive number, and you're going to go with the sign of the middle term here. So if the middle term is positive and the last term is positive, again, the last term tells you whether your signs are the same or not. Since the last term is positive, our signs are the same, and our signs will be whatever the middle sign is. So the middle sign here is positive, so my signs will be plus plus. And then since this is an easier trinomial, we're looking for two things that multiply to be 6 that combine to be 5. Two things that multiply to be 6 and combine to be 5. Choices would be 1 and 6 or 2 and 3. If they have to combine to be 5, they're going to be 2 and 3. So again, if you had something like 5x squared minus 5x plus 6, again, since 6 is positive, that means your signs are the same, and they'll be whatever the middle sign is. So this is going to be x minus, and again, an easier trinomial means we can say what multiplies to be 6 and combines to be negative 5x. That's going to be the negative 3 and the negative 2. And you could check that if you wanted to. So just showing you a couple of examples where the last term is positive. In number 46, the first thing that I notice is that I do have a greatest common factor in number 46. And the greatest common factor between all my terms is a 2. So we're going to factor out a 2. And we're going to say 2 times what is 4x squared, and that's going to be 2x squared. 2 times what is negative 14x, that's going to be negative 7x. And 2 times what is negative 8, that's going to be a negative 4. And then we have a trinomial, so we have to keep factoring here. So when it says factor completely, this would be a situation where when I factored out the GCF, I had a trinomial that would factor again. So I have to keep factoring until I factor completely. I need two things that multiply to be 2x squared. That's going to be 2x and x. And then I need two things that multiply to be negative 8. So since 8 is negative, my signs are going to be different. This is a harder trinomial because of the 2x squared. So I cannot say what multiplies to be 4 and combines to be negative 7. That doesn't work in this situation with a harder trinomial. So you're just going to put in two things that multiply to be 4, negative 4. So we could start with positive 2 and negative 2. If that doesn't work, then we can try positive 4 and negative 1, or we can reverse that and do positive 1 and negative 4. But let's check here. Outer terms multiply to be negative 4x. Inner terms multiply to be 2x. So do negative 4x and positive 2x combine to be negative 7x. No. You could change the 2's, but you wouldn't get anything different because those are the same numbers. So we know it's not 2 and 2. So we've got to try something else that multiplies to be negative 4. So we're going to try 1 and 4. So now my outer terms multiply to be negative 8x, and my inner terms multiply to be positive 1x. And ask yourself, does a negative 8x and a positive 1x give you the negative 7x? And it does, so you have the trinomial factored correctly. So this is what we would call a two-step factoring problem where we had to factor the GCF out first, and then our trinomial ended up factoring in a 2x plus 1 times x minus 4. Number 47 is what we call the difference of squares. And we know that the difference of squares factors into two binomials. We know that we need two things that are exactly the same to multiply to be 49x squared, so that's going to be 7x times 7x. We need two of the exact same things that multiply to be 36. That's going to be 6 and 6. And because 36 is negative, I have to have two things that have opposite signs. So that means that one of my binomials will be plus, and the other one is going to be minus. If you wanted to check this out, you can multiply the outside terms. They give you a negative 42x, and the inside terms give you a positive 42x, and negative 42x and positive 42x will cancel each other out. That's why you see no x term in the middle of your binomial. There's no x term here, it's just an x squared and a constant term. That's because the two 42's are opposites and they actually cancel each other out. So this would be your two factors for number 47. Next set of directions are asking us to solve by factoring. So we look at our problem to see if it may already be factored. And remember, we also have to make sure that the right-hand side is set equal to 0. So good thing is the right-hand side is set equal to 0. Bad thing is the left-hand side is not factored. Okay. In order to solve by factoring, one side of your equation has to be set equal to 0, and the other side has to be factored. So the left-hand side is not factored, but it's a trinomial, and we know how to factor trinomials. It's an easier trinomial, so I can do x and x. 36 is negative, so my signs are going to be different. And since this is an easier trinomial, I can say what multiplies to be 36? That combines to be 9. So it could be 1 and 36, it could be 2 and 18, it could be 3 and 12, or it could be 4 and 9. And since one of my numbers is going to be positive and the other one is going to be negative, I'm looking for something that's going to actually subtract to be that middle term of 9. So that's going to be 3 and 12, because 12 minus 3 is 9. I have to get a positive 9, so that means my 12 needs to be positive and my 3 needs to be negative. Once I have factored correctly, then I have a rule that's called the zero product principle, and it says if two things multiply to be 0, then those two things could actually be equal to 0. So you set your first factor equal to 0, you set your second factor equal to 0, and then you solve those two little equations to get your solutions. So we end up with a negative 12 for one of our solutions, and we end up with a positive 3. Negative 12, positive 3. Almost finished. Number 49. If we're solving by factoring, one side of our equation has to equal 0. Right now the right-hand side is equal to 30. Can't be equal to 30. So let's move that 30 over to the left-hand side. So it's a positive 30, so we're going to move it by subtracting. We now have a trinomial. On the left-hand side, x squared minus x minus 30 is equal to 30 minus 30, which is 0. So now one side is equal to 0, which it has to be, and the other side is a trinomial and it is not factored yet. So I'm going to do my two binomials. This is an easier trinomial, so I'm going to do x times x. 30 is negative, that means our signs have to be different, and I'm looking for two things that multiply to be 30 and combine to be an understood negative 1. And since our signs are different, then we're actually going to be subtracting these factors. We're looking for something that subtracts because our signs are different. Subtracts to be a negative 1, and that's going to be 5 and 6. Now I need to have a negative 1, so that means my 6 needs to be negative and my 5 needs to be positive. So just make sure you factored correctly, and then if my two factors multiply to be 0, that means the factors actually could be equal to 0. So solve, we get two solutions, negative 5 and positive 6. Alright, last one. If we're solving by factoring, again, we have to have one side equal to 0, and it is not equal to 0. So I'm going to subtract 60. I'm going to get x times x minus 4 minus 60 is equal to 0. We really don't need x times x minus 4. That's not going to help us factor, so let's go ahead and simplify that out by multiplying or distributing the x. So we get x times x, which is x squared, x times negative 4, which is negative 4x, minus 60 equals 0. So now we're in good shape. One side is equal to 0, the other side is a trinomial, which will factor. We're going to do x times x. We picked a lot of problems that had this last term being negative. So just to make sure you understand, if the last term is positive, that means the signs have to be the same, and they'll be whatever the middle sign is. But if the last term is negative, then that means the signs are different. And then we're looking for two things that multiply to be negative 60. Remember, one's positive, one's negative, so that really means we're going to subtract these numbers to get our middle term of negative 4. So it could be 1 and 60, 2 and 30, 3 and 20, 4 and, 4 and, how many times does 4 go into 60? 15 times maybe. And 5 goes into 60. How many times is 5 going to 60? I have to do that. I don't have a calculator handy. Sorry, guys. Have to do it the old-fashioned 4th grade way. 12, I knew that. Do 5 and 12 subtract to be 4? No. And so then there is 6 and 10. 6 and 10. 6 and 10. I have to have a negative 4. So if I have to have a negative 4, that means 10 has to be negative and 6 has to be positive. So then we're going to set each factor equal to 0 and solve. And we get our two solutions, negative 6 and positive 10. I hope this has helped you.